We've all seen large language models do some pretty amazing things. They can write code, they can draft emails, they can even whip up a poem on the spot. But they still feel, well, a bit passive. They wait for our prompt, for our next command. They can think, sure, but they can't really do anything on their own. And that brings up a really good question. If an AI is smart enough to understand a complex request, why can't it take the next step and actually execute a task? Like booking a flight without me having to guide every single click. Well, that gap is exactly what AI agents are designed to fill. By the end of our time here, you'll understand the fundamental shift that lets an AI move from just answering questions to autonomously getting things done. So let's break this down. The core difference really is about moving from passive thought to proactive action. Think about it this way. A standard chatbot is reactive. You ask a question, it gives you an answer. It's a simple, one-shot interaction. But an AI agent? It's proactive. You give it a high-level goal, and it goes off, creates its own plan, and then executes that plan. It's the difference between being knowledge-based and being action-based. This brings us to a much better way to think about agents. They aren't just clever tools. They're more like assistants that have a degree of autonomy. Formally speaking, an AI agent is a system that can perceive its digital environment, make a plan, and then use the tools it has available to achieve a specific goal. The key word here, the one to really focus on, is autonomously. So here's the mental model to hold on to. You don't use an agent like a calculator, where you have to punch in every single number in operation. You use it like an assistant. You don't tell your assistant how to book a flight. You just say, find me the best flight to London for next week. The agent figures out the rest.
So how does an agent actually pull this off? Let's take a quick look under the hood at its core components.
The engine that drives an agent's intelligence is a large language model. You can think of the LLM as the agent's brain. It provides all the reasoning and planning capabilities it needs to understand a goal and figure out a path to get there. An agent basically operates in a continuous cycle, sometimes called an agentic loop. First, it gets a goal. Then it plans how to achieve it by breaking it down into smaller pieces. After that, it uses its tools to execute those steps. And finally, it learns from the results to do better next time. The first critical skill in that loop is task decomposition. A vague goal like plan my trip is basically useless to a computer. The agent's LLM brain has to break that down into concrete subtasks. 1. Find flights. 2. Check hotels. 3. Compare prices, and so on. Now, an LLM's knowledge is static. It's frozen at the time it was trained. To act in the real world, an agent needs tools. This is where tool calling comes in. It allows the agent to interact with external systems. It can call a weather API, search the web, or query a database. This is how it breaks out of its own knowledge bubble. And finally, a good agent learns. Through what we call iterative refinement, it watches the results of its actions. It stores what worked and what didn't in its memory, and it uses that feedback to self-correct. This lets it adapt and improve over time. It's also worth knowing these agents didn't just appear out of nowhere. They're built on decades of AI research. We started with simple reflex agents that just followed if-then rules. Then came model-based agents with memory, then goal-based agents that could plan, and now, finally, the learning agents we're seeing today. Okay, that's enough theory. Let's make this a little more concrete with a real-world example. Imagine you give an agent just one high-level goal. Plan the best week for a surfing trip to Greece within the next year. So here's how that agent might think. First, it decomposes the goal. Subtask 1, analyze the weather. But its LLM brain doesn't know real-time weather, so it makes a tool call to a weather API. It gets the data back, but it still doesn't know what good surfing means. So it creates subtask 2, define optimal conditions. For that, it makes another tool call, maybe to a different, specialized agent. Finally, it pulls all this info together to give you a single recommendation. And you can see this same pattern playing out across tons of different fields. Engineers are using agents to automate software development, handle complex customer support tickets, perform data analysis, even underwrite financial loans. The objective is always to automate these complex, multi-step workflows that need both reasoning and access to outside tools. So, if you're going to remember just one thing from all this, let it be the core concept that ties everything together. The single defining characteristic of an AI agent is autonomy. It is the ability to independently plan, act, and learn to achieve a high-level goal without needing a human to micromanage every single step. Ultimately, this is the paradigm shift.
AI is no longer just a source of knowledge, it's becoming a tool for execution. You could say that AI agents are the very mechanism that moves us from thought to action.